So we were just talking about how if the original function doesn't pass the horizontal line test, then the inverse won't be a function. So right now we have a parabola here, and we can see that it is not passing the horizontal line test. If we draw a horizontal line, it's going to touch 2 points. The question is saying, write the equation of the inverse each time, and we need to determine 2 ways to restrict the domain. Now for a parabola, it becomes quite easy to see 2 ways to restrict it. If you think about where your vertex is, so our vertex is right here at 1, 3. Can you see that everything to the right of 1, 3, if I color that, I'll use a highlighter. I'll highlight in green on this side. If I just had that green part, can you tell that the inverse would be a function? And I'm going to highlight the other side in blue. If I just had the blue part, then the inverse would be a function. Well, I'm going to graph it, and I'm going to graph the green part and the blue part with those different colors. So starting with my vertex, which could be in either color, I have the point 1, 3. If I switch x and y, I would have the point 3, 1. Agreed? If I choose another point on my green graph, can you see that you have this point right there on the green part, which is 2, 4? If I change the x and the y values, I would have 4, 2. And so I'm going to draw this over here in green to represent the highlighted green part that we started with. That would be the inverse of just part of it. And then if I just had the green graph, can you see that that green graph is a function? Okay? So one way, and we'll do it completely for the green section first, one way to restrict the domain would be to say that if I just want the highlighted green part, the x values would be bigger than or equal to 1. And if I restricted it to just bigger than or equal to 1, then my inverse, which I drew here, is a function. The green one is on the right. So x is bigger than or equal to 1. What would the equation of that inverse be? Well, I'm going to do some work here to the side to show you. Remember, we find an inverse algebraically by switching x and y. So if I switch the x and the y to start off with, I would get this. Move the 3 over, square root both sides, and remember the plus or minus. Add 1 to both sides, and I'm going to add that 1 to the end, y plus 1. That gives 2 equations, one with a plus, one with a minus. Can you see that on our green one here, we would have the plus 1, the positive 1, because our square root graph has been moved 3 to the right and 1 up. The second way is on the left-hand side when x is less than 1. If you took points like this one, 0, 4, it would go to 4, 0. That would be the bottom part to that parabola. And if you think about what its equation would be, well, it's been reflected over, move 3 to the right, and 1 up. That would be the equation for the second one. You can have less than or equal to or just less than. So questions 10 and 12.